Hello and welcome to all of you. My name is Greipl and I'm pleased to briefly introduce you to our work on facial and bodily expressions of emotional engagement, and more specifically how dynamic and objective measures reflect the use of game elements and subjective experience of emotions and effort. Game-based environments and gamification are treated as promising ways to promote engagement. Ample research evidence suggests that engagement is related to better educational outcomes and of primary importance in education and training. Our study specifically focused on aspects of emotional engagement. There is agreement in the literature that adding game elements increases the enjoyment of a task that is otherwise perceived as boring. One could say emotions are at the heart of games. From a psychological perspective, emotions impact everything that passes our senses from perception to remembering information. Additionally, tasks with game elements can be perceived as less effortful than tasks without game elements present, and there may be a potential link between the subjective experience of effort and emotions, and if so, between bodily features, which is why we included this measure in our study. Previous attempts to capture emotional engagement through objective measures successfully showed that such measures provide additional and valid information to traditional subjective assessments. The current study, however, tries to utilize the obtained continuous data more comprehensively by analyzing changes across time and their variability. Our main research questions were: can we generally relate expressive bodily and facial features to the use of game elements? And can subjective effort alongside positive and negative emotions be meaningfully mapped onto objective expressive components of emotions, such as facial and head activity features? To address all of these questions in one experiment, we added game elements to a classic working memory task well known from the psychological domain, the spatial two-bag task. In the original task, our participants needed to perform 240 trials as follows. In each trial, a blue square was randomly presented in one of 4 locations on the screen. After presenting this stimulus, participants had little less than a second time to indicate the location of the stimulus presented 2 trials prior to the current trial. This original task was now enriched with game elements, such as a narrative, a graveyard design with zombies, individual scoring system, and a progress bar. This way we created a non-game condition in which participants performed the original version of the task, and a game condition in which participants played an actual game. Most importantly, both tasks only differ in terms of aesthetics. They are, however, completely the same with respect to their basic mechanics. All body features or all objective measures were examined from live head recordings of our participants during task performance, and the footage was automatically analyzed using the software OpenFace. Regarding facial expressions, we obtained 18 so-called action units, which are part of a taxonomy of distinct facial muscle actions. Certain combinations of action units result in familiar expressions of emotions such as happiness. Likewise, action units can indicate the valence of an expressed emotion, for instance, whether an emotion is pleasant or unpleasant. For these features, we calculated slopes that indicate a general in- or decrease in intensity of an action unit over time, and a parameter that represents the variability of the intensity over the course of the recordings. To briefly sum up the measures we used in this study, there were facial expressions as action units obtained with the 2 measures previously mentioned. We also examined head pose parameters such as head movements in space and head tilting, but these are omitted from this presentation for brevity. Finally, participants were surveyed about their emotions and their subjective experience of effort throughout the experiment. When looking at the results, some anticipated patterns emerged. Action units that were significantly related to the absence of game elements, such as nose wrinkler or blink, were negatively balanced ones. The latter may even function as an indicator of boredom, which seems plausible when playing without game elements. The relation of emotional expressions to subjective ratings of emotions and effort was partly successful. While almost no action units could be tied to positive emotions, those units usually prevalent in the context of negative valence were frequently significant predictors for negative emotions. Facial expressions that predicted subjective effort remained largely ambivalent with respect to their valence, reflecting that subjective effort unifies both negative and positive aspects of emotions. Interestingly, our latent parameters were exclusively related to the use of game elements, whereas the variability parameters were much more prevalent in indicating subjective ratings. What is safe to conclude is that emotional expressions were able to successfully indicate the use of game elements, and they were likewise meaningfully associated to the subjective experience of emotions, strengthening the positive link between game elements and emotional engagement. Most notably, however, it was surprisingly rarely the case that the same emotional expressions were associated to the same variable across conditions. For instance, if an action unit was related to negative emotions in the game condition, it was many times not related to negative emotions in the non-game condition. We may therefore conclude that our diverse results on the expressive component of emotions and subjective effort best fit the assumption that feelings that arise while or because of doing something critically depend upon the individual and the context. Finally, it remains a challenge to realize the full potential of process measures of emotional engagement using computational methods. Thank you so much for watching.